In the previous lecture, I discussed cladistics fairly extensively. I'll now continue on the topic of systematics. Whereas systematics is the reconstruction and study of evolutionary relationships, classification refers to how we place species and higher groups, genus, family, class, and so forth, into the taxonomic hierarchy. An artificial classification is based on one or a few characters, simply for ease of identification or for a specific purpose. For example, birds are often arranged according to habitat, and habitat, while fungi may be classified as edible or poisonous. Such systems do not reflect evolutionary relationships. A natural classification is based on resemblances and is a hierarchical arrangement. The smallest group commonly used is the species. Species are grouped into genera, the hierarchy continuing up through tribes, families, orders, classes, and phyla to kingdoms, and, in some systems, to domains. Higher up in the hierarchy, the similarities between members of a group become fewer. Present-day natural classifications try to consider as many features as possible, and in doing aim to reflect evolutionary relationships. Natural classifications are also predictive. Thus, if an organism is placed in a particular genus, then it can be assumed it is likely to possess most, if not all, of the other features of that genus. Systematics and traditional classification are not always congruent. To understand why, we need to consider how species may be grouped based on their phylogenetic relationships. A monophyletic group includes the most recent common ancestor of the group and all its descendants. By definition, a clade is a monophyletic group. A paraphyletic group includes the most recent common ancestor of the group but not all its descendants. And a polyphyletic group does not include the most recent common ancestor of all members of the group. In systematics, describing a group of organisms that contains all the descendants of a particular single common ancestor. In cladistics, such a grouping is called a clade and is the only type of group regarded as valid when constructing classification schemes. Hence, the monophyletic grouping of Theria contains the marsupial and placental mammals, together with their extinct Mesozoic relatives, all of which share an immediate common ancestor, not shared by the more distantly related egg-laying mammals. Similarly, birds and crocodiles are the living representations of a monophyletic group, Archosauria, and are more closely related to each other than to other living reptilian descendants. Consequently, the grouping reptiles, used in many modern classification systems, is not monophyletic but paraphyletic, since it excludes the birds. In systematics, describing a group of organisms that excludes one or more descendants of a particular single common ancestor. For example, the taxonomic group reptiles, used in evolutionary systematics, is paraphyletic because it excludes birds and mammals which share the common ancestor as reptiles. In cladistics, such groups are regarded as invalid when constructing classification schemes, since cladistics allows only monophyletic groups or clades as a basis for taxonomic groupings. However, in evolutionary systematics, paraphyletic groups or evolutionary grades are sometimes permitted to reflect biological similarities. Thus, reptiles is used as a group because its members are closely related to each other, and they share certain essential characteristics such as ectothermy that differ markedly from their fellow clade members, the birds and mammals. Describing a group of organisms that contains the descendants of two or more different ancestors, while excluding other descendants of a single ultimate common ancestor. Such a group may be constructed on the basis of certain shared traits, which may have evolved convergently, but it does not necessarily reflect any close evolutionary relationship. and is therefore rejected as a basis for phylogenetic classification. For example, mammals and birds share the trait of endothermy, but the grouping endotherms is polyphyletic because its members have quite different immediate ancestors, and the defining trait evolved independently in each member. The name archosaurs is given to the monophyletic group that includes a crocodile, Stegosaurus, Tyrannosaurus, Velociraptor, and a hawk. Some, but not all, taxonomists traditionally give the name dinosaurs to the paraphyletic group that includes Stegosaurus, Tyrannosaurus, and Velociraptor. This group is paraphyletic because one descendant of the most recent ancestor of this species, birds, is not included in the group. Other taxonomists include birds within the Dinosauria because Tyrannosaurus and Velociraptor are more closely related to birds than to other dinosaurs. Bats and birds could be classified in the same group, which we might call flying vertebrates, because they have similar shapes, anatomical features, and habitats. However, their similarities reflect convergent evolution, not common ancestry. Taxonomic hierarchies are based on shared traits, and ideally, they should reflect evolutionary relationships. Traditional taxonomic groups, however, do not always fit well with a new understanding of phylogenetic relationships. For example, birds have historically been placed in the class Aves, and dinosaurs have been considered part of the class Reptilia. But phylogenetic advances make clear that birds are avian theropods. Therefore, having two separate monophyletic groups, one for birds and one for reptiles, including dinosaurs and crocodiles, as well as lizards, snakes, and turtles, is not possible based on phylogeny. And yet the terms Aves and Reptilia are so familiar and well established that suddenly referring to birds as a type of dinosaur, and thus a type of reptile, is difficult for some. Nonetheless, biologists increasingly refer to birds as a type of dinosaur, and hence a type of reptile. In a preceding lecture, you heard about several different ideas concerning what determines whether two populations belong to the same species. The biological species concept, BSC, defines species as groups of interbreeding populations that are reproductively isolated from other groups. In recent years, a phylogenetic perspective has emerged and has been applied to the question of species concepts. Advocates of the phylogenetic species concept, PSC, propose that the term species should be applied to groups of populations that have been evolving independently of other groups of populations. Moreover, they suggest that phylogenetic analysis is the way to identify such species. In this view, a species is a population or set of populations characterized by one or more shared derived characters. The concept of a species as an irreducible group whose members are descended from a common ancestor and who all possess a combination of certain defining or derived traits. Hence, this concept defines a species as a group having a shared and unique evolutionary history. It is less restrictive than the biological species concept in that breeding between members of different species does not pose a problem. Also, it permits successive species to be defined even if they have not evolved in an unknown line of descent with continuity of sexual fertility. However, because slight differences can be found among virtually any group of organisms, the concept tends to discourage extreme division of species into even smaller groups. This approach solves two of the problems with the BSC. First, the BSC cannot be applied to allopatric populations because scientists cannot determine whether individuals of the populations would interbreed and produce fertile offspring if they ever came together. The PSC solves this problem. Instead of trying to predict what will happen in the future if allopatric populations ever came into contact, The PSC looks to the past to determine whether a population or group of populations has evolved independently for a long enough time to develop its own derived characters. A novel evolutionary trait that is unique to a particular species and all its descendants, and which can be used as a defining character for a species or group, is phylogenetic terms. An apomorphy that is restricted to a single species is termed an autapomorphy. It alone cannot provide any information about the phylogenetic relationships of that species, although it can indicate the degree of divergence of a species from its nearest relatives. An apomorphy illustrated in figure, that is, shared by two or more species or groups, is termed as synapomorphy. Such traits define and strictly monophyletic groups or clades, which are the basis of cladistic classification systems. By definition, a clade is monophyletic. A paraphyletic group contains the most recent common ancestor, but not all its descendants. A polyphyletic group does not contain the most recent common ancestor of all members. The phylogenetic species concept focuses on the possession of shared derived characters, in contrast to the biological species concept, which emphasizes reproductive isolation. The PSC solves some problems of the BSC, but has difficulties of its own. An evolutionary trait that is homologous within a particular group of organisms that is not unique to members of that group and therefore cannot be used as a diagnostic or defining character for the group, i.e. plesiomorphy. For example, vertebrae are found in Equus, Acinonyx and Pongne, but the common ancestor in which the trait first evolved is so distant that the trait is shared by many other animals. Therefore, possession of vertebrae sheds no light on the phylogenetic relations of these three species. An ancestral trait that is shared by two or more groups because of their ancestral origin, symplesiomorphies, are not usually helpful in assessing more recent evolutionary relationships within a larger group. We'll continue with phylogeny in the next lecture. See you then.